Welcome back. We're now at essentially part C, I suppose we can call it. We've already done a circuit analysis just turning on V1 and keeping the two current sources off. Then we turned off V1, turned on I1, kept I2 off. Now we're going to keep V1 off, turn I1 off, and just keep I2 on. So again, when we turn off a current source, we've got infinite impedance, infinite resistance, so this becomes an open circuit. When we turn off a voltage source, this becomes a closed circuit. So here we go. And I'm going to draw fairly quickly this time because we're assuming that I've gained experience as I've been answering this question from before. So here we go. I'm going to start on the right side where this current source is. So I'm at this node right here. That's this node. So here's I1. And now I'm going to meet these resistors at this node. There we go. And then this is a closed circuit down to ground. So I could actually have done this. So again, these resistors are just in parallel. So I know from previous experience that this I can replace with a single resistor to ground of 4K ohms. And I can combine these two resistors. So let me simplify the circuit one more time. And again, I2, by the way, is known as at 2 milliamps. So this is what I've got. And now we're going to do some circuit analysis and try to figure out the voltage contribution. Didn't I just make a blunder? We are turning I1 off, so this is all an open circuit. And that's the great thing about supposition. I could have, superposition. It didn't matter if I turned it off immediately or I simplified the circuit, turned it off, and then make whatever changes I need to. It looks like I can make one further change because now this makes the 2K and the 4K in series with each other, and I can redraw. So 2K and 4K is just a 6K resistor. And there we got our current source I2. So actually that's a much cleaner drawing once I realized my mistake here that I had left current source I1 on. And again, that's just because these two are now just in series. So this is what I've got. And now I can do the same analysis I did before, same type of analysis, which I can introduce some currents. So I'll just call this IA, call this IB. And I'm actually looking for this voltage, but what I'm going to do is I'll just call this my VA again. So VA must equal to the drop across this resistor, which is IA times 6K. And then for this part of the loop, I've got VA must equal to the voltage drop across these two resistors, which are in series. So this is IB times, well, it's IB going down minus IA, because IA is going up. That's also going through this wire, times the total resistance, which is 10K. And then we have a third equation. It turns out right here that I2 must equal IB. So this equation simplifies to VA is equal to I2 10K minus IA 10K. I can solve this side for IA. I can solve this side for IA. Well, I can just plug this into IA, and we've got VA is equal to I2, which remember is known. That's just 2 milliamps times 10K minus VA over 6K, which is what I'm substituting for IA, times 10K. And let's see what we get. We should, since we're trying to find VA, let's solve for VA. 10 over 6 just becomes 5 over 3. So we have VA over 1, factor out VA, equals 1 plus 5/3. I can simplify this to 8/3. I can solve for VA, and we've got I2 10K times 3/8. I2 is 2 milliamps, so that's 2 times 10 to the minus 3. 10K is 10 to the 3 times 3 over 8. These cancel. The 2 simplifies with the 8, and so we have VA is equal to 3/4. And since I maintain MKS system all throughout, I know this is in volts. So this is the contribution. Well, hang on. This is just VA. We know that we're actually looking for V5 right here. V5 is a simple voltage divider, which is just VA 4 over 4 plus 6, K. So VA is equal to 4 over 10, or VA times 4 over 10, or VA 2/5. We know that VA is 3/4. And we get 3/10. So V5 is 3/10 volts when only current source 2 is turned on. So, turns out the test gave us a little chart, if I can find it here. Here we go. The test gave us a little chart. That we can fill in. So we just filled in that from current source 2 we got a contribution of 3/10 volts. From current source 1 we got a contribution of 1.5 millivolts. These are volts, so they wanted in volts, so let's rewrite that as 1.5 times 10 to the minus 3 volts. And from the original V1, looks like we got V1 times 3/8. And now there is a last part to the question. It says, based on your above expressions, change V1 such that the current through R6 is going to be 1.5 millivolts. So let's figure that out. Let me get a new blank piece of paper here. All right, here we go. So we know that through, we just got to consider now this resistor R6. And we know that the voltage across it we call V5. And we found right here from our chart, V5 is equal to V1 times 3/8 plus 1.5 millivolts, which we'll call 3/2 times 10 to the minus 3, plus 3/10 volts. And that we got from that chart. And they want us to change this voltage so that the current through here is 1.5 milliamps. Well, what was this resistor equal to? This was a 6K ohm resistor. So simple Ohm's law, V5 must equal the current through the resistor, which is equal to, they wanted to set it to 1.5 milliamps, so 3/2 times 10 to the negative 3 amps times R6, which is 6 k ohms. And we can set that equal to this because we know this is what V5 is equal to. So 3/8 V1 plus 3/2 10 to the minus 3 plus 3/10 is equal to 3/2 10 to the minus 3 times 6 times 10 to the 3. Alright, let's figure this out. So these cancel. We're left with 9. Then we've got to subtract 3/10, subtract 1.5 millivolts, divide by 3, multiply by 8. Sorry about that. Divide by 3, multiply by 8. Let you take a moment to absorb this. So we've got V1 is equal to, I can factor out a 3 from here, from here, from here, and that'll cancel with this 3. So I have 3 minus 1/10 minus 1/2 times 10 to the minus 3, all of that times 8. Now I could just use a calculator and be done with this, which in a test is what I would do, but I'll just impress you with my fractions. We have, let's see, this is 30, this would be 30/10, so this is 29/10 minus 10 to the minus 3 halves times 8. And plug that into the calculator, and whatever you get is, it's going to be close to, looks like something less than 24 volts or so. And I hope that, I guess I might as well just plug that into a calculator. And I'm just using a trusty TI-83, which hopefully you have something better. Yep, so 23.196 volts, approximately. Final answer. So if we set V1 equal to that, the current through R5, will actually equal the 1.5 milliamps they're asking for. So my new V1 should be 23.196, as long as I didn't make any mistakes. So pause the video, stop the video, review it, see if I made any mistakes. Feel free to let me know. Good luck.